So a robot uses states and reactions from sensors via callbacks to complete the second level task. The robot publishes to command veil topic and to provide location for the robot. Subscribes to the LiDAR, depth camera, and the color camera topics. The initialization phase runs once at startup just to populate all the variables to make sure that they're not null. The system works with a main loop, which is called every 0.1 seconds. The states are roam, chase, contours, push, forget, and evade. The roam state roams around the room, turning left or right to try and find the space, and will drive forward if there's enough room in front of it. The chase contours will move left or right, depending on whether the contour is to the left or right of the image. And if it's in the center, it will push. It transitions to the push state. The push state measures the distance to the wall and pushes for that amount of time. The forget state is used to stop it from focusing on a block that's already been completed. And it basically just is a timer and turns in a random direction. So there's an element of randomness to the program, which can help get around sticky items. The evade state is used to reverse away from items that are too close, and it also turns slightly when it's reversing. Some of the features I have in my system are the isValid function, which uses the distance from the die to the wall using the depth camera and the LiDAR for the wall. If the robot's too close to the wall, it won't use that, won't be valid. Another one is another interesting feature is my find pixel angle, which uses the angle, which uses a pixel location and uses the FOV of the camera to find the angle of that pixel. And then I've got the find range of that pixel, which uses the LiDAR of that angle to give me a LiDAR reading. This is how dies are determined as to whether they're close to the wall or not. Another interesting function I've got is the average depth, which uses a structuring element to find the average depth around a pixel rather than the pixel itself to eliminate noise. Another function which I've got is the LiDAR left, right, center function, which gives me a left, right, and center distance, allowing me to determine which way to turn.